All right, the room is filling up. So I'll go ahead and get started with some of the housekeeping items. Hello again, and thank you for joining us. I am Tanya Marvin, Marketing Coordinator at Simulations Plus. Dan O'Connor, who's our Director of Business Development, who has this beautiful tropical background. He'll introduce our speakers for today. In this webinar, Dr. Raymar Lobenberg, Professor, Faculty of Pharmacy and Pharmaceutical Sciences at the University of Alberta, and Dr. Daniela Silva, Postdoc Fellow at Simulations Plus, will showcase the use of GastroPlus for a pharmacy course. So just a few housekeeping items before we begin. We take your privacy rights seriously. By attending this event or participating in the Q&A session, you are allowing us to contact you for follow-up. You may ask questions via the questions panel on your dashboard at any time. If you need assistance, please use the hand raise icon. And we'll address all the questions in the Q&A after the presentation. So I'll turn it over now to Dan.
Good morning, all, and thank you very much, Tanya. This is actually a very exciting presentation for me. Within the last year, we introduced what we call the University Plus program, which is an effort on the part of Simulations Plus to offer to qualified universities and academic institutions software at no cost, any of our software on any of our platforms. And today we have the opportunity to listen to both a professor and a student, future professor, who work together to evolve within their own university a course look at modeling and simulations, principally around our GastroPlus platform. So we have the opportunity to listen to Dr. Lobenberg, who is a professor, director of pharmacy and pharmaceutical sciences, and one of his doctorate fellows, who's now a fellow with us, Daniela Silva, here at Simulations Plus. So without further ado, let me turn you both loose to share your experience in dealing with students, learning, modeling and simulation, and the next generation of scientific forwardness within the university space.
And real quick, Dan, before we get started, we just have a couple poll questions we want to run.
Well, that's only because I'm on the beach. I didn't remember that, sorry.
Okay, so let me launch the poll here. All right, got two questions for you. So are you currently enrolled in the University Plus program, which Dan just talked about? And then which title best describes you? So we'll give everybody a few seconds. Got a lot of responses coming in. I'll give it just another second or two. Still got some responses coming in. All right. Looks like everyone has answered. So let me end and share the results. So here are our results. So the majority, 61%, are not enrolled in University Plus program. I will share some information in the chats and links for more information. And then for Daniela and Raymar, the title that best describes you, we've got other is the top. And with that, I will stop sharing and I will turn it over to Daniela and Raymar.
To present about active learning in a pandemic, teaching biopharmaceutics with GastroPlus. This will be a webinar together with Daniela Silva. She was at the time a student in my lab, and we wanted to give you a little overview of how we approached this challenge with the pandemic and what we did and what we found and what probably there might be certain things we would also like to carry over in when the world is again a little bit normal. Daniela, any comment from your side?
And yes. Hi, everyone. Just also wanted to thank Simulations Plus for this opportunity. Also to show for us to show how we kind of tackled our teaching experience during the pandemic scenario. And we hope that you can take some of the lessons learned from our example.
So we had to rethink how student learning can be improved in this online world, and how the interaction can be fostered in a pandemic online environment, because I, as a professor, really saw that maybe 10% of students got really very good learn online. The others had really problems, and then of the people who had a problem, around a third nearly could not learn online. And this is, of course, for a university, a big challenge, and for the educational system. And also, I mean, Tanya, USTA, what was your experience with learning for the students?
Yeah, it wasn't easy, because obviously all the time you're just staring at a screen with just their names. So you have no idea whether or not they're there even, or if they're learning. So sometimes during the lecture or during the class when we're in person, you can kind of tell, right, whether or not they're understanding by their facial expression, and then you can gauge your audience basically. And whereas when you're in an online environment, that's very different to very difficult to assess. So it I think not only made it difficult on the learning part, but also on the teaching part, and how to engage the students in this environment.
Exactly. So our objectives were then, we wanted to engage the students for more active learning. And there came a discussion Daniela and myself had, can't we do a computer lab instead of a real lab, in-person lab, where we use GastroPlus and we teach the principles of drug absorption online, but much more interactive, you know. And then also through these exercises, we hope to get encourage critical thinking about bioavailability and biopharmaceutics, because the students had to do it online, but still they had to do the exercise on the computer in a group and discuss this. And even if they're in different locations, at least when we started this, we saw that the students got more engaged, that they begin to discuss and not just consume, because this is the problem with most of the Zoom meetings. You are just to consume, you just consume, and then when the telephone rings, you run to the telephone or do something else. So the distraction is very big, and through that we could get them getting, even if they were online, more engaged. And then our question was, can we carry this over into a normal world? And we will come to this a little bit later. Yeah. So here the outline. I will give a very short theoretical background about biopharmaceutics. Then we will live show you GastroPlus, the program and the exercises we did. So the different tabs GastroPlus has, the compound tab, gut physiology, pharmacokinetics, simulation tab, the graphic tab. Then we will show you some examples which we did with the students, and then we give some conclusions. Okay. Modern biopharmaceutics, I think, started with 1995 with Dr. Gordon Amidon, when he put out his landmark paper, Theoretical Basis for Biopharmaceutical Drug Classification, the correlation of in vitro drug product dissolution and in vivo bioavailability. And I think this is really where modern biopharmaceutics started. Before that, we every time guessed what a drug is, and now he began to classify drugs and look for what we as formulation scientists and pharmacists are interested in. What makes a drug bioavailable? And for that, we have the first principles. Oh no, before that, we had only solubility as one of the criteria. Something is poorly soluble, probably not good bioavailable. Other parameter which was used a lot at this time point was then the log P. But as we know, log P is just for the neutral species. It's not the molecule in a pH-dependent environment. So drug development before the BCS was quite, yeah, you were shooting into the dark and you were hoping you hit something. And we had certain parameters where we knew if they are positive for us, we might have a chance, but we didn't know really where things go. So next slide. And I think biopharmaceutics has been defined as the study of the influence of formulations factors on the performance of a drug product. And we measure these things often with pharmacokinetics, where we have the rate of a process, absorption, distribution, and metabolism, and excretion of a drug in a body. And that means differences in biopharmaceutics will, in most cases, also end up in differences in pharmacokinetics. Okay, and for that, we have to know the first fundamental of this biopharmaceutical drug classification system is only what is dissolved can be absorbed. So if you eat stones, stones come out. So only what is dissolved can be absorbed. The second fundamental is only what is absorbed can be studied in vivo. That means if you have a beer and the alcohol is not absorbed, you don't get drunk. No? But if something gets available, then we can have it in our body and it might go to the site of action. Next slide, please. For that, we are able to, or we should be able to simulate drug absorption. Because if we have a drug and we have the gut, here you see the yellow tube, this is the gut. And when we have then fixed law applied to the gut wall, then we should be able, when we know the surface area, when we know the dissolution and the solubility of a drug, the surface area, we should be able to simulate drug absorption in the gastrointestinal tract. Next slide. For that, the BCS has defined the 4 classes: BCS class 1, highly soluble, highly permeable; BCS class 2, low soluble drug, which are good permeable; then solubility, the class 3, high solubility but low permeability; and then the class 4 drugs, of course, low solubility and low permeability. For that, what is high solubility? What is high permeability? At the moment, high solubility is when a drug substance can dissolve in 250 milliliter of an aqueous buffer solution between pH 1 and 7.5. This number changes from guidelines to guidelines a little bit, but generally that's the definition. And highly permeable is when the extent of absorption nowadays is 85% or higher of a drug. Then it is assumed to be highly permeable. So next slide here. This is the graph. Dr. Amidon called him his $1 million graph because the study cost $1 million, where they perfused humans and measured the permeability of the drug in vivo in humans, and found that, yeah, there is a border between high permeable and low permeable, which is here at the number 2 around, as you can see. And then drugs which have a low permeability will probably also have problems with their bioavailability. Next slide. That different numbers were developed. The first number is the dose number, where the dose of the drug goes in, the water, the solubility of the drug, and the water. The water is the part of the glass of water you should use to take your drug. Yeah? And this is nowadays 250 milliliters in clinical studies. But as you can see in the next slide, when you take less water, the pharmacokinetics might change dramatically between different drugs. So the amount of water is an important factor when it comes to taking your drug. Next slide. Besides the dose number, there's a dissolution number, here the radius, and again the solubility are major factors. Of course, density, diffusivity are going also into it, and gastric transit time. However, the major parameters are probably radius and the solubility of a drug. And when we look into literature, go to the next one. Thank you. If you go to literature, then we see, yes, a gross powder has caused a very low pharmacokinetic. Then when we decrease the particle size, the pharmacokinetics, the exposure gets more and more. And if we put a solubilizer into the drug particles, then we even get a further increase. And can you make the next? Yeah, this means here we have the particle size, the radius, and here we have the solubility increase through a surfactant. Now, next slide now. And the last number is the absorption number, and here the major factor which we can measure is the effective permeability. The radius of the gut we can't change, the transit time we can't change. So for us, the absorption number is probably the one which is very important when it comes to the permeability of it. Good. I think with this, we come directly to the end of this very short theoretical introduction. So we can have problems with the dose number. We can have problems with the dissolution number. However, here we know that formulation might be able, like radius changes or putting a surfactant into a formulation can increase the dissolution number, but this can also have an influence on the dose number. On the other hand, when we have a problem with the absorption number, yeah, then we have a problem with the molecule, and probably then the only way to improve is getting another molecule. Good. Which brings us now to our examples we want to show you with GastroPlus. And we will change here very quickly into program. And second. Yeah. Good. Daniela, can you explain to us the compound tab from GastroPlus?
Sure. So yeah, basically here, what we're going to do is also what we did with the students, and so that they could also understand what are the different components of the program and also for them to get exposed to this tool, and even at an undergrad level. So basically here in the compound tab, we would show them that from this demo database, they could select from the different compounds that are in there. And here, the molecule, the structure would be shown, and then they could check the formula, the molecular weight, log D, and what pH that log D was referring to, as well as they could play around with the dosage forms. So firstly, we started with an immediate release tablet, but then we also wanted to see, for example, a gastric release to see how that would impact or not the pharmacokinetics. And as Dr. Lobenberg mentioned earlier about dose volumes, so here where we would input that volume, that what volume was used when the person or the patient was taking that drug. And here on the right-hand side, we can also see those three numbers. So the dose number, absorption number, and dissolution number. So with that in view, the students could readily see what kind of problem they would be having with the particular drug they were dealing with. So in the case of piroxicam, the first thing they would see is, well, I do have a high permeability value. And that is also confirmed by the green background in the absorption number. However, both dose number and dissolution number have a red background. So that means I will most likely have a problem with solubility. And then we would work around those problems and see how we could circumvent certain problems. So
next thing we looked at it was the pKa table on the right side. And show the students when they click on this what we see there. And here we see two main tabs. The first one is the Solubility tab. And since you see in the table there is pKa values given, so depending on the physicochemical properties of a drug, its solubility can be pH dependent. And here on the green line, you see very nicely that this drug is not very good soluble between pH 2 and pH 6. In very low pH, it is better soluble. and beyond pH 6, its solubility again increased. Yeah. Guide us through log D.
Sure. And then log D would basically be the opposite, right? So when we have a highly soluble drug, most likely, or a pH where the drug has a higher solubility, so that's probably because the drug has a charge. So the log D or the permeability will be lower at those pH values. So that's what we can see here between 0 and 2. And then as the molecule gets into a more not charged state, then you have that increase in log D, and then it decreases again where you have that increase in solubility. So, sorry, go ahead.
This is where we spend quite a little bit of time switching backward and forward with the students between these two tabs, and ask them the question, what do they see and what do they think, so that they really see these factors are both very important factors, but they go in different directions. So if solubility goes up, permeability probably goes down, and vice versa. And this was the first step where the students began to understand, yeah, solubility is important, permeability is important, but they are not independent of each other. When something gets more soluble, its permeability will probably go down.
Right. And also we would make them think, so okay, so this is the solubility profile that I have in this pH range. So when I look into my gastrointestinal tract, how is the drug going to behave in different segments? So here with that would be a good segue to go to the gut physiology, so where they could assess the pH value in the different compartments of the gut, and then think about, okay, so in the stomach for this particular drug, I have a pH of 1.3. So what is going to be, how my drug is going to behave in that particular pH? So when the dosage form reaches the stomach, so do I expect my drug to dissolve in the stomach or not? And of course, each group received or were assigned a different drug. So that exercise would be, it would depend obviously on the drug that they would be working with.
In the pharmacokinetics tab.
And yeah, and then in this case, since we were heavily focusing on formulation parameters and things for them to think about the biopharmaceutical properties of their product, or whatever they were simulating, if it was, just go back here to compound tab, if it was an immediate release or a controlled release. So in this demo database, the pharmacokinetics is already set. So in this case, they would just glance at it. We didn't, for this particular class, we didn't do anything related to pharmacokinetic parameters, so that they would change things here. So the only thing that we did ask them to assess was liver extraction, to see how it would look like if their drug is more metabolized or not. But the focus, like I said, was mostly on physical chemical properties of the drug. And then, yeah, and then firstly, we would ask them to run a single simulation with all the default values, right? And one thing also to mention here about the gut physiology, we would also ask them to assess whether the physiological state would affect the performance of their drug, either if it was in a human fasted or fed state. So here we're just going to show, for example, with everything as a default, so an immediate release tablet with fasted state, and we would just run the simulation.
Then you have to go to a graph tab. So the simulation tab only fills in this table you see, but then when you want to see the pharmacokinetics and want to analyze what happened, you have to go to the graph tab.
Here, let me just do a simulation for the whole length of the observed data. So basically 120 hours.
Let's do the simulation again. Okay, and the graph. Yeah. And now, Tanya, show us, beside, this is now the dots are the clinical observed data, and the blue line is the simulation, of course. But what else can we now look into? When we
Right.
discuss the plus?
Yes. So here we would also go down here to the different plots. So here they would just see, okay, I have obviously a good match between observed and predicted data. But what does this tell me? They wouldn't be able to tell much about what is going on with the drug or how to interpret these parameters, for example, dose number, absorption number, and try to understand these parameters into the simulated profile. So this is would be when we would come to, for example, absorption and dissolution. And here we would start asking questions. So for example, they're seeing that the red line is the amount dissolved. And I see that it is readily dissolved. And we would ask, okay, so what do you think that's controlling absorption here? Is it solubility or is it permeability? What is the main issue with the drug here? And then we would move down, for example, to regional absorption. So here for this example, we had basically 100% of the dose that was administered absorbed and reaching systemic circulation. But they would also be able to see that in the jejunum was the part where the drug was mostly absorbed in. And going back here, they would understand that, and also interpreting these results, that permeability is not a problem. Now we would say, okay, so if permeability would have been a problem, let's say that your drug was actually 1.04, and here, or it would go even below that. So the number changed to red here. So what would you expect that profile to look like? So here they would run a simulation again. So then they would understand why is it that permeability was not a problem here. So here, for example, they would see that, well, it is dissolving quite fast in the first hours because the drug is in the stomach. And as we saw here back in the pKa table, that in a low pH value, the drug has a higher solubility, so we wouldn't have a problem there. But then when it moves on to the, whoops, sorry.
Yes, yeah. Was to probably to change back the permeability. But no.
Okay, so yeah, so here I'm just running into 24 hours. So when it's in the stomach, it's readily soluble. And then when it changes pH values based on the time, here we see that it went, now it entered into the duodenum or the intestines where the pH increases to a pH value that the drug is not as soluble. And because the drug, we just changed the solubility, or sorry, the permeability, because the drug is not being absorbed quite readily as it would have been, we see some precipitation going on. So that's why we're seeing this bump in the curve here. And then they could see that here, obviously, what was dictating the absorption is the permeability.
This is very typical that when we have a problem with permeability, the blue lines, so the amount absorbed and the amount dissolved, really are far away from each other. However, when we have that dissolution controls the process, then the red line and the blue line are very close to each other. This is one of the things to really visualize the importance between dissolution controlled absorption and permeability controlled absorption. Okay, Tanya, please.
I will move this back. So the next thing that we would ask them, so for example, for this particular drug, we saw that we would now look into the regional absorption. So like I showed before, we saw that the jejunum, so we saw that the jejunum was where most the absorption was occurring with an immediate release tablet. And here, then we would change to a controlled release gastric release tablet. And so then we would explain to them that the tablet would then be retained in the stomach for longer. And for this, we would just create a dissolution profile. And here, just very simple. So then they would be able to see, for example, I don't know, 10 hours, we would have 100% release. And with this, then they would be able to run the simulation and compare. And so we would use the table, the data that we just created for a dissolution profile, and then try to understand when they looked into the pharmacokinetic profile, they saw the CP time. Let me just run 120 again. And here's just using that profile that we created. So here, what they would understand from this is that, from the first 10 hours, this is just following the dissolution profile that we provided, and then this is just described by the pharmacokinetic parameters that is elimination. So from the body. So what additional information can I get from solely looking into this, into the CP time? I can really mechanistically understand what's going on, but then when we move on to the regional absorption, what they saw that even though the total amount absorbed didn't really change, they saw that because the drug was being retained, or the product was being retained in the stomach, where the drug has higher solubility for a longer period of time, it basically creates a supersaturated solution that when it reaches the intestine or the duodenum, it's readily to be absorbed. So the absorption will occur much faster, or like at a greater extent in the duodenum, as opposed to the jejunum, as we saw previously with an immediate release tablet. So here they would see how the formulation can impact the absorption pattern, not so much the total amount absorbed, but the absorption, the region absorption. So let's say if this would be a drug that is absorbed primarily in the duodenum, either because of transporters that are being more expressed in the duodenum, or for whatever reason it is. So this, for example, would have been a good approach for that particular drug, because then I am shifting that absorption pattern to the duodenum. Do you have anything to add?
I think we can now go to the next exercise we did with them, which was the PSA particle size, how particle size can impact.
So here we
just. So we made a parameter sensitivity analysis for that. We let the students discuss a little bit about what would be interesting, and but we helped them a little bit to find the right parameters, because particle size, as we saw in the earlier slide, can impact. Now the question is, how much would it impact? This is the nice thing here with GastroPlus. We can say here the particle radius and run a simulation and ask the program, estimate for us what will happen when we change the particle size in between a smaller and a higher parameter we set, and the program will now do, as you can see here on the screen, at the moment 4, 5, it makes 10 simulations where it looks into it, what happens if I have 10 different bins of particles. And then we go back to the graphic part. And now we can choose here in this menu on the left side, different parameters, for example, Tmax, what happens with Tmax. So on the y-axis, x-axis, you see the particle size, the radius from small to large. And as you can see, up to 11 probably micrometers, the curve really does not take off, but then suddenly it takes way quickly off, and that means Tmax would increase after probably 10 microns significantly. Let's have a look at Cmax. What would happen with Cmax or Cmax or AUC? As you can see, they will decrease by pretty much 50%. When we look at this here, 155, and the biggest particles is under 1. So we would have a significant impact on the particle size could have on our Tmax, on our Cmax, and probably also on our AUC. And when we go a little bit deeper, then we look at bioavailability, percent bioavailable. There we would see the bioavailability would only go down after 30 microns of diameter. So this is where we can look into these parameters, Tmax, Cmax, how they get changed, yes, changed, but when it comes to the bioavailability, there we see again, there we need much bigger particles. Yeah. Good, and with this, I think we can move on to furosemide, our second drug which we used. As you can see here, everything is directly red.
So with the furosemide example, we would show them that now we have a drug with already a low permeability, so we wouldn't have to play around with that value. And as you can see here, the red background, and also we would compare. So now, how is the solubility looking like here? And we see that as opposed to piroxicam, the drug is not very soluble in the stomach. So then we would ask, would it make sense for you to use a gastric release, since the drug is not soluble in the stomach anyways? And then we would let them discuss this principle as well. And then we would also look at the log D, and they would also see that it was the opposite of solubility. And then we would then do an immediate release tablet simulation. And here, then they would see for the CP time, we have that curve. They couldn't really get much information about it. But then when we come to regional absorption, they would see that. And also here with this, the output, they could see that, well, 50% is being bioavailable, as opposed to piroxicam that had nearly 100%. So here they would also be able to see the regional distribution. And when looking then into the absorption dissolution plot, they would clearly see that, yes, it is permeability that is playing a role here in the absorption of this drug, because it is readily dissolved. And even if it is readily dissolved, but it's the green curve is not following this dissolution, the dissolution curve. So that means we have a permeability problem.
So then let's have a look into what would happen if we do a gastric release, besides the fact that it might not have any, makes no sense, but how would everything look like? So now let's have a look. As you can see, the red curve is the dissolution curve over 10 hours, the profile we have set. And yeah, absorption goes behind, but look at the total amount absorbed. There is not a big difference, right? So even if we had a slower release out of the stomach, the overall percent absorbed is the same.
And also here we would point out that as opposed to piroxicam, where they saw that huge increase into duodenum, here they didn't see it. One, because the drug is not really soluble in the stomach, so that means that whatever is reaching the duodenum is not necessarily dissolved, and the drug is a low permeable drug. So they would be able to see then that for this particular drug, having a gastric release makes no sense.
But what would now happen if we take a dosage form, which is not an immediate release dosage form, but a dispersed system, which would go through the gut and dissolve on its way through the gut? So a dispersed system. Let's have a look what happened here, also for the same dissolution pattern. And now look at the total amount bioavailable absorbed, only 18%. So you can see here, so a dispersed dosage form would decrease bioavailability. And this is because drug has to dissolve and is slowly absorbed and goes through the gut. And as you can see in the colon is quite, most of the drug is absorbed in the colon. Yeah? Which has not the best. Now the next question we asked the students, so if we now do a particle parameter sensitivity analysis, how can we improve the bioavailability? So we would go back to the parameters, select the parameter, go again to we go to the formulation, and do the particle radius again, and do a parameter sensitivity analysis. So what would be the hypothesis? That yes, decreasing the particle will probably improve the bioavailability.
Yeah, and another aspect that the students thought, well, permeability as well. So it's not like then we would sort of like do the exercise so then they would understand what permeability would look like.
And the program.
I'm sorry, let me just, I have to stop.
Yeah, you need to release tablet, Good. As you can see, the program again makes 10 runs of parameter sensitivity analysis. We choose 10 because then it doesn't take the whole day. So we can increase this also, but I think for the principle of showing the students what parameters do, I think 10 simulations are good enough. Spider plots, and now we can choose again in the spider plots, for example, Tmax and Cmax. So let's see, Tmax would stay quite a while long the same, up to 25 microns, and then Tmax would increase. Cmax. So here for Cmax again, probably up to around 20-25 microns before the plasma concentration would significantly decrease. And let's have a look at the bioavailability. AUC first. So as we see, bioavailability would not change very much from 50% to 45% if we have very large particles. So as you can see here, particle size has some impact, but not the same impact as for piroxicam.
And for example, for AUC also, we see that there's generally like over Cmax, Tmax, we saw that there was this plateau from 25 micron radius below. And then we would also, because many times they have, or we have that concept that if you micronize something, then you have an increased exposure, or AUC will be greater. So this, we also showed them how this can be a very powerful tool to set specifications, for example, particle size specifications, that if you do micronize it under 25-ish micron of particle radius, you're not necessarily going to have a higher exposure.
Now let's have a look at the permeability or permeability impacts, the AOC. So you can see, yes, if permeability increases, and when you look here, 0.15 to 0.13, you would nearly double your AOC also, yeah? Let's have on Cmax and Tmax. As you see, same tendency for, so this drug is really depends on its permeability. All permeability really controls the performance of the drug. And here for Tmax, as you can see, Tmax will go down, will increase over time. Yeah. And have a look at the percent bioavailability when the yeah, as you can see here, like with Cmax and Tmax, percent bioavailability would also increase if we could increase the permeability. But as we learned earlier, permeability is one of the things we unfortunately can't change easily. Okay, yeah. With that, I think we wanted to come to our conclusion of this seminar. I think critical thinking about biopharmaceutics through visualization and PK of regional absorption profiles enables the student to better understand the interplay of chemistry, physiology, dosage form, and the PK profile and bioavailability. And I think, Daniela,
yeah, and
last point.
Sure. Yeah, we saw that this active learning and the student engagement, with that, obviously the class will mostly be a part of a post-pandemic learning. And we did see that because this exercise was done in smaller groups as well. So we divided the class into groups of 12 students. And then a group of 12 students was then further divided into groups of 4 students. So obviously they were able to really go in depth into the discussions and really understand and have that exchange of and really rich discussions. And we would be moderating the session as well and be with them. And it was just very, very good to see how they were being able also, because they had access to the software. Each student had their access to a cloud, to a virtual machine where they could play around with the software on their own. So that was a great exposure and definitely helps them to grasp these concepts.
Yeah, and to be able to manage 130 students, we made different rooms where we then went from room to room. So we were not with all the students all the time. We went from room to room and saw and asked and discussed with them what they were just doing or if they had a problem. And that way we could deal with a rather large group of students and still get the students engaged, discussing things and checking sometimes things with them or saying, what do you think? And we saw then also when we had exam and everything, the biopharmaceutics part in the exam improved. Students got the answers better. More students got the correct answer. And we have also written a paper about this, which is just these days published about these exercises. And if you're interested, we will be more than happy to provide you with a reference to this. With that, I want to thank you all, and we are ready for questions if you have so. Thank you.
Thank you.
Morning, everybody.
All right, real quick before we jump in with our live Q&A, we've got one more poll. So let me launch that. All right. So how applicable was the overall webinar material to your future course planning? We'll give it a couple seconds to let all the answers come in. So far, it looks like very applicable is winning. Just give it another couple seconds here. All right, I'm going to end the poll and I'll just share the results real quick. All right, so very applicable at 76%. All right, now we can go ahead with our live Q&A. So I'll turn it back over to Dan, who can help us moderate that.
Thank you very much, Daniela, or excuse me, Tanya. Got to remember who you are. I thought I'd just share a quick fact that I did a quick search online this morning, looking at the number of jobs that are out there when you search PBPK. There's 209 jobs in the US currently open. If you search GastroPlus in that same website, the website is a job finding website called Indeed, there are 129 jobs. So from an academic standpoint, offering your future graduates the opportunity to find a wealth of opportunity out there is just one of the many reasons that the University Plus program's in place here at Simulations Plus. And the first question that I'll address was one that was put to us about licensing procedure. How can multiple students, say a class of 10, all access the software? And I think we heard that particular question answered, that we can provide a cloud license that would allow access to numerous students and support you in that realm as well. So I know Tanya has put the link so that for anyone that would be interested in learning more about the University Plus program and how we can support your teaching or research, doesn't always have to be teaching, we'd be more than pleased to help you in that regard. Now we have a few questions about the presentation itself, but before I jump into some of the more technical, I'd just like to ask a question of both of our presenters. What do you think the greatest learning was for the students in your courses? I mean, and from a conceptual standpoint, working in modeling and simulation, is there something that you could share, maybe a new aptitude that's gained or a new appreciation for what these tools can bring?
Yeah, if I can start with this. Sorry, my camera does not start at the moment. I think what we saw, that the students got a much better understanding of this interplay between physical-chemical properties and what happens in the body, and what are the different factors. So when you see a pharmacokinetics, this looks nice, but what is the mechanisms behind it? And this is often where we saw the students not really understanding this, because they never had to critical think about what happens in the body and what happens with the different interfaces we have, what happens in the stomach, what happens in the gut, what is permeability, what is solubility, and how do they interact, what happens when we have a different release pattern. And I think this is where the students really gained a lot of understanding, and the feedback we got from them also was, yeah, now we really understand this now much better. Daniela.
Sure, yeah, and on top of that, so this was a PharmD class, and one of the things that I found really interesting was students reaching out to me afterwards to say, well, I really like this, and what kind of, like, asking me what kind of jobs can I get actually in industry, because now I'm really interested in that area of pharmacy or pharmaceutical sciences. I do still, of course, like the patient care part of it, but I'm kind of like quite intrigued now to see how would a career look like in the industry, because sometimes these programs, they're much more focused on the clinical aspect of their learning. So it was great to see that they were also exposed to the other facet, I guess, of pharmaceutical sciences and how they can be of value, obviously, in the pharmaceutical industry and in the research setting.
Yep. Well, that's very exciting. And again, that's the direct theme of what the university program is all about. First question is, can you simulate in different disease conditions like aging people, neonates, critical care patients? So is that addressable in the modeling and simulation platform?
Actually, we have done that many years ago. So you have to take then the gut physiology tab and have to change the parameters there. So for example, permeability in babies is different than in grown-ups. You can also have, for example, if you have certain diseases where the motility is impaired, you can change the transit times in the different pieces of the gut to simulate certain disease conditions. So yes, you can, but you have to know a lot about the disease and how the disease impacts the gut physiology.
Yeah,
Right.
and
Go
yeah.
ahead.
Sorry, yeah, just addressing as well. So for neonates, for example, or aging people, we do also, because here in this example, we showed a compartmental PK model, but obviously if you have a PBPK model, then within GastroPlus, we have the paraphysiology as well, where you can set the demographics of your population, and then the software will on its own address all of those physiological changes based on age and some of the disease conditions as well are already incorporated in the software.
Right, thank you very much. Can you apply this to specific delivery systems like liposomes or nanoparticles?
For nanoparticles, yes, you can. Well, if you do have a release, a controlled release with these particular systems, then you would input in there the release profile, and then you can use that release profile that is linked to your formulation. And also you can play around with the particle size. If you're just talking about a nanocrystal, for example, you can play around with the particle size. And then now if you come to liposomes where you have a different kinetics of digestion in the gastrointestinal tract, like Raymer said, then you have to understand to be able to parameterize the formulation that you're using.
Great. I do have a couple requests for the paper that you cited. So we'll make sure that anyone needs the address to that they can have that as well. A couple of questions about handling different PSC class drugs, how that can be accommodated within the software. How do you address the different absorptivity there?
Do you want to chime in, Raymer?
Yeah, 1 second. Sorry, man. Yeah, so there was this one question. So with solubility and permeability, and if BCS class 1 drugs are exception to this, not really. It is, every molecule has this interplay when it's at least pH sensitive, that we have the solubility can be influenced in certain ranges of the pH, and then the lipophilicity might change also here, but class 1 drugs are normally have enough solubility and enough permeability to be highly absorbed. So here we don't see so much the effect. It is more, that's why we also use the example of furosemide, where we have the permeability as one of the problem parts of the molecule, because as you saw, or if you recall, the permeability or the log D was in the stomach at low pH was quite good, but then the log D really decreased dramatically when the pH changed from low pH to pH from pH 4 around, dropped dramatically, so that when drug comes out of the in the stomach, the drug is not soluble really. So when the drug then comes and dissolves in this duodenum, where the pH is 5 and 6, the drug, yes, stays in solution, but is not good permeable. And this is different with class 1 drugs. They have a good solubility and a good permeability throughout the physiological pH range.
Well, again, I think, thank you both. We've come up against our deadline here. Tanya, back to you.
All right, thank you, Dan. And Raymer and Daniela, I appreciate your time today. I know we had a lot of questions that we didn't get to, so Any of those, we will answer live. We'll post them on our social media. And I put those links in the chat so you can find those there. This webinar has been recorded for playback and it will be available on our website and our YouTube channel. Again, I put those links in the Q&A. There were several questions regarding that. So this concludes our webinar for today. Thank you for joining us.
Thank you very much.
Thank you very much.